I didn't record. All right, so we're going to be talking about how to calculate energy. So we talked about the two different types. We talked about kinetic energy and potential energy. All right, and we're going to start today talking about potential energy. All right, so I'm going to kind of skip around just a little bit so we kind of hit the high points, and then we'll come back and talk about some other stuff. Okay, so if you're following along on your notes, make sure you're on the correct slide. Okay. All right, so conservation of energy, we kind of talked about this just a little bit already. We're going to skip past this open and closed systems for just a second. And we're going to go right here to this law of conservation of energy, all right? Energy, just like mass and matter, can never be created or destroyed. Never. You cannot just magically make whatever, heat, okay? It has to come from somewhere. It can, however, change forms. It can change forms. So we talked about, for example, okay, Gary, let's say I plug up my laptop, okay, and I turn it on. So what type of energy am I starting with?
Electrical.
Yes, electrical. I plugged in my laptop, so that's electrical. Now I've turned on my laptop. That electrical energy can now change into another type of energy. Somebody tell me what kind of energy it could change in. It's a couple of them.
Light.
Okay, right. Eric says it could change into light energy. Exactly. Otherwise, you could not see anything on your screen. What else do you notice? Very nice. Sound energy as well. Thank goodness I can turn on my laptop and I can hear some stuff, okay, if I happen to play anything. Anything else that it could be converted into?
Thermal, I think up sometimes.
Very nice. It could also convert into thermal energy. I don't know if you've ever sat a laptop on your lap before, but they get pretty hot, okay? They can get hot from all that electrical energy moving around and changing into thermal energy. Someone last period also brought up a good point and said that there is chemical energy because most laptops also have a battery. So like if it's not plugged up, like some of you guys are using your tablets right now or your Chromebooks, and they're not plugged up, but they're running off of a battery. Okay, so that's also chemical energy. All right, so the big thing on this is you can't create or destroy it, but it can change forms. Okay. All right, so this is just talking about how it happens when it changes forms. So we talked about plugging in your laptop. Right here, this girl is on top of a stair or something. It's a really long stair, right? But she's holding this ball. It's not moving, so that's potential energy. But as soon as she drops it, as soon as she lets go, it changes into kinetic energy, okay? As soon as she lets go, it changes into kinetic energy, okay? And remember, if you're filling in the notes, I did skip a couple of things, but that's okay, all right? So, and you may be on the picture that has a dog. I'm getting there, okay? All right, so here's another example of a parked car and it starts to move. It goes from potential to kinetic. All right, here's a roller coaster. If you're sitting at the top, you know how I like click, 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 gets to the top, and then it's not moving, potential energy. Then as soon as it starts to move, it goes down the swoop, it changes into kinetic, okay? All right, and then this little silly dog, I don't know what's going on with him, but he's rolling down a hill. At the top of the hill, he has potential energy, then he starts rolling, and that turns into kinetic energy. All right, so let's talk about specifically potential energy, all right? Sometimes you will hear it called gravitational potential energy. Let's just make a note of all the different ways you can see potential energy written, okay? So sometimes you'll see just the main letters for this. So you may see G, P, E, okay? You may see GPE. You may also see just PE, which is potential energy, okay? You may also see a capital E and then a little p, which means it's an energy. What type of energy? Potential, okay? So anytime you see PE, GPE, or EP, those are all potential energy, okay? All right, so that is potential energy. Let's talk about what it is. We already know okay? Or hopefully, because we talked about this last week. But it is, potential energy is energy that is stored. It is stored energy, okay? Stored energy, all right? Stored energy. It has to do with position or arrangement. Position or arrangement, okay? All right, this, don't worry about this, but this is not correct. That is a type of kinetic energy, but nuclear and chemical are, okay? All right, so potential energy, usually position or arrangement, specifically a lot of times, let's make a note of this, specifically, a lot of times when we're talking about position, we're talking about height, okay?
So get rid of the thermal energy picture, just like that.
Yeah. Okay. All right. So remember I said the higher you are, the more potential energy you have. Okay. All right. So now we're coming to the equation. All right. And I'm going to do the rest of the class period. We're going to work through some equations and then I'm going to open up one of those quizzes. All right. Here is the equation for potential energy. Notice this time they wrote it with an E and a P and a little P. E and a little P.
Could I join the Zoom and like go stand in one of the factors?
Yeah, you don't even have to join it. Why do you have to join it?
Let's see.
You can't see from, okay, that's fine. All right. So let's make sure that you got this equation down. M, somebody online, tell me what does M usually stand for when we're talking about M? Or Pamela, you know?
Mass.
Very nice. Kevin and Pamela both said mass. Excellent. All right. H will be our new one, but H is height. Okay, H is height. And then we've talked about G before. What did G stand for before?
Gravity.
Excellent. Gravity. All right. So let's make sure we got those down. All right. If you want to make a note, H is going to be height. That's our new one. Okay. And height is usually measured in meters. Very nice. So you may see meters, you may see centimeters, you may see kilometers or kilometers. All right. Mass, this is mass. What do we usually see for mass? Anybody remember?
kg.
Excellent. Kg. Very nice. And then gravity, there's a number that we always use for gravity. It has not changed as of yet. 9.8. Ooh, that looks rough. Let me erase that. 9.8. All right. So this is what's going to happen a lot of times. You're going to see when you get ready to do a problem, it's going to look like you're missing a number, but that's because they're not going to give you gravity. But you should know that gravity is always 9.8.
Negative, right?
Say again?
Negative 9.8.
Or just 9.8. No negative on this one, okay? And just in case you're wondering, it's usually meters per second squared, okay? But, so remember, you're going to look for, so here's how you know where to plug things in. Remember, the important thing is looking at your units. So if I see an M, that's meters, I know to plug it in right here. If I see kg, I know to plug it in right here for mass, okay? And then this number right here, this G will always be 9.8. All right, now, here is something, I'm gonna wait to tell you about that, okay? We're gonna talk about, sometimes they only give you one number and I'm gonna tell you why sometimes, okay? Because sometimes they just give you newtons. All right, so let's clear this. Everybody got this down?
Yup.
Okay, all right. So now let's try a practice problem, okay? It says a flower pot with a mass of 15 kilograms is sitting on a windowsill 15 meters above the ground, okay? And it says how much potential energy does the flower pot contain? All right, well, this one's pretty self-explanatory. So kg, remember kg, this one always goes in for mass. Now we're lucky on this one because on this one, the numbers are the same. So it really doesn't matter, right? I could put 15 here or here, but this says kg, so I'm going to put it here. And then this 15 is meters, so we go here. And again, remember, I'm not going to give you gravity, but you should always know it's 9.8, okay? So this is what it would look like. 15 times 9.8 times 15. Remember, if it's in parentheses, all that means is it's being multiplied. So this is 15 times 9.8 times 15. All right, and when we multiply that, we get this 22.05. And instead of writing this long unit, we say joules, okay? So joules is the unit for energy, unit for E. Okay, so anytime I'm asking you to solve for E, whatever number you get, 10 joules, 22.2205 joules, 13 joules. That's the unit for energy, okay? All right. So now you need a calculator, okay? This is where you try. Now, let me just give this heads up. Let me pause my recording for a second. All right, so we're going to start our practice problems now, and that's what we're going to do for the rest of class, okay? So I'm going to clear all of this. All right, so this is the first one we did. Now, let me explain this next question, and then I'm going to go back and forth for a second. This next question says, if the flower pot is lowered, okay, to a windowsill that is 10 meters from the ground, what is the potential energy now? So it's the same flower pot from this problem, okay, but now the height is different. Same flower pot from this problem, but now the height is different. So I'm just going to mark this one, okay? So what they're saying is now it's at 10 meters. So now you are telling me the answer if it was at 10 meters, okay? So I'm going to pause this and you guys tell me the answer. All right. So yes, so let's look and see what you should. Did you calculate it, Leo?
No? Oh, no, I don't have to.
Okay, come grab one of these calculators. All right, so let's see what you should have gotten. All right, so I said it said, now be careful. I said it was, when we looked at the next one, I said it was the same flower pot. So the flower pot didn't change the 10, it still was 15. So you should have gotten 1470 joules. All right, here's the next question. All right. What is the gravitational potential energy, which is just this EP, of a 10-kilogram book that is placed on a shelf that is 2.5 meters high? Remember that if you look at your units, that should tell you where to plug it in at. All right, so try that one, private chat me. All right, so it looks like most of us are on the right track. I answered that one super fast, fantastic. You should have gotten, Leo, did you already answer?
245.
Leo got 245 and he is correct. So instead of writing out this whole kilogram times meters per second squared times meters, you can just write joules, or you can just write a capital J, okay? Now, let me show you because this next one is kind of tricky, all right? Now, here's what this one says. What do you, oh, no, it's not. All right, you guys do this one, and then I'll show you the next one. It's kind of not tricky, but I have to show you something, all right? So guys, go ahead and do this one, and then we'll do one more and we'll be just about done, okay? All right, let me point out something because I just noticed something when I was looking at Eric's, okay? And this is really important. This is what I was going to show you on the next one, okay? All right, on some people's guided notes, instead of saying kilograms, this says, oops, this says newtons, okay? Now, if it says newtons, that makes a difference. So you need to be listening right now because this is really important, okay? All right, if you ever look at this, please make sure you're paying attention because this is really important and you're gonna miss it, okay? If it says newtons, what that means is they have already multiplied M times G, okay? Now, if it says kilograms, they have not multiplied by G, which is what we've been doing. So a lot of you guys got 2, 4, what was it, 6, 9?
Yeah, 2469.6. That's what I did.
All right, this is correct if it says kilograms, okay? If it says newtons, what they're telling you is they've already multiplied by G, which means you would just do 12 times 21, okay? If it says newtons. So if you ever see it and it says newtons, like the next problem, okay? So you can try the next problem if you want. If it says newtons, then you don't have to multiply by G because they already did it for you, okay? They already did it for you. So if you, Eric, what did you get right here?
For that one, I got 252.
All right, so if you did it where it was newtons, it would be 252 joules, okay? So let's try the next one because that one definitely says, okay, Kevin, that one definitely says newtons. So let's do that one. Let me clear. Okay. All right, this one says newtons. So everyone should be, so this is where it says right here. Let me show you. When, oh, that was not what I wanted to do. When given weight, just multiply by height. I don't know how I did that, but when given weight, just multiply by height, okay? So this is really important. So if you can highlight this on your notes or circle it or put a star.
So we're just multiplying by 20 and 79?
Correct. Excellent. So you should just, very nice. Good, good, good. Carla and Allie, excellent. Okay. So you have to be careful. Yes. You have to be careful if it says newtons versus whether it says kilograms. Okay. That's the biggest thing.
I'm not understanding.
Sounds good.
All right. If it says newtons, like it does right here, then they have already multiplied the mass. They've already multiplied the mass and the gravity together. So M times G is equal to 79 right here. Okay. They already had a mass and they already multiplied it by 9.8. And when they did that, they got 79. So now, instead of multiplying 79 times G, they already did that for you. So you don't have to do that. So this M times G, that is equal to 79. Yes. So now what do I need to do to solve for EP or potential energy? 79 what?
Height,
Times height, which is what?
20.
Which is 20. Excellent. That's only if it says newtons. Now, if it has said kg, Leo, if this has said kg, then I would still have to do times 9.8 and then times 20. Okay. Only if it says kg. Okay. All right. You guys did so good today.
This doesn't, hold on.
What did you get? Tell me what you got. Huh?
I didn't get anything. It doesn't.
Did you do 79 times 20?
I'm saying it doesn't work. This calculator.
Okay, go get another calculator. Here's one right here. All right, so what you should have gotten is, okay, hold on. What you should have gotten is 1580 joules, okay? 1580 joules. Excellent. All right. So, you guys did really good today. Actually very impressed. Okay. All right, there is one more, but I'm not gonna make you do it because it's the same thing.
100. Oh no, 1580.
Yes, that's what you got. Excellent. Okay.
Should I copy it?
Yes, you can copy it. All right, I'm gonna save this recording.